Now, if the mass falls in this direction, because this thing can rotate in either direction, if we just counterbalance just a tad bit in this direction, happens to fall this way, how fast is it going when it hits the 45-degree position? The position being measured counterclockwise from the positive horizontal direction, from the rightward horizontal direction. In this case, our displacement is from here to here. Now that's a vector, and we can calculate the components of that vector. How far over, how far down do you have to go to get here? And there are various ways we could do that, and I've kind of outlined those. Gravitational force is still straight downward, so your picture of your displacement and your gravitational force looks like this. And of course that depends on how long you draw your gravitational force. But the gravitational force then projects onto delta S. This projection is the component of gravitational force in the direction of delta S, and that's what you multiply. You multiply this component of the gravitational force by your displacement. That's where's my yellow chalk? I've left off a couple of symbols. Nothing should distract you. So we project gravitational force onto delta S, and the work done is our projection of the gravitational force on delta S multiplied by delta S. Okay? Now this is scalar projection. It's just what you get when you calculate this side of this triangle here that we've looked at before. So it's drawn kind of poorly right here, but you get the, you know the idea. And this, of course, is your gravitational force parallel to delta S, the parallel component of the gravitational force. And I didn't really call it that, and I probably should have. But I've used the projection notation, and I'm going to kind of leave it that way and just say that's F grav parallel. Multiply that by our delta S, being a little sloppy with notation here, but you get the idea. And that is the component of the gravitational force in the direction of delta S, or parallel to delta S, multiplied by delta S, and that's the work. And that is the F grav parallel times delta S. So that's the work done by the gravitational force. It's the definition of work when you have a constant force and a constant displacement. Okay, now the question is then, how would you go about calculating this? Okay, how do you go about calculating the components of the vector delta S and then finding the projection of this on this? Well, ultimately, you need to know the angle here. And there are many ways that you can figure out this angle. So I'm going to expand this a little bit and talk about different ways you can find the angle.